Hello students! So this video here is solving linear and nonlinear systems algebraically, part 2. Alright, so guys, in that last video, in part 1, we started talking about solving linear systems algebraically, and we had briefly discussed some things about linear equations and some different ways that linear equations can be written, some different forms that linear equations can be written in when we're doing systems of linear equations. And then we started talking more about some different ways algebraically that we can solve linear systems of equation. In that last video, we were able to go over some examples using that first method that I introduced to you guys. That first method that we had discussed and looked at examples of was the substitution method. So again, guys, the substitution method is a method that involves substituting or replacing an equivalent expression, and again, we replace that equivalent expression or for a solved variable, and we put that equivalent expression into the other equation. But again, guys, in part 1 of this video, we went through 2 or 3 examples of using this first method that we talked about, substitution method. Guys, the second method that we never had a chance to actually go into and look at examples, at least not in that last video, part 1. But again, the second method is the elimination method. I think I had mentioned it in the first video. But again, it's called the elimination method. And again, sometimes it's referred to as the addition method. Okay, so guys, this second method, the elimination method, or again, it's sometimes called the addition method. This is a method that involves creating equivalent equations by multiplying one or both of the equations by a constant factor, and we'll only multiply one or both of the equations if it is absolutely necessary. And so we may have to multiply one or both of the equations by some constant factor if it's necessary, and we'll do that so that when when those two equations are added, so that when those equivalent equations are added, one of the variables will be eliminated. And so again, the goal here is to be able to get those two equations in a particular place where when we add them together, one of the variables will be eliminated. So again, the goal is to get the two equations, if they're not already that way, so that when we add them, one of the variables will be eliminated or canceled out. So again, if you're not getting what I'm saying with that, you will in just a moment when we go through the examples for this. I promise. All right, so let's look at a few examples with using the elimination method, or the addition method. All right, so let's look here. Let's say that we were doing the example right here. And oops, might want to put that on a pen, so we can write. Alrighty. Okay, let's say here that we had the example 4x minus y equals 29, and negative 2x plus y equals negative 15. Alright, so if we had this example here, I want you to notice something here. So guys, remember, I said that with using the elimination method, the goal is to be able to add those two equations together. The goal is to be able to add those two equations together with the hopes of, or with the final goal of being able to cancel out one of those variables, right? So if you notice here, guys, you should notice that if we add these two equations together and just kind of focus on the like terms, right? You see how the like terms are lined up? The 4x and the negative 2x. So if we added those two together, just think real quick, right? Just think. Put on your thinking cap. If we added those two together, that would give us positive 2x, right? What would happen if we added negative y plus, and we added a positive y, right? What would happen if we added negative y to positive y? Wouldn't that make that variable cancel out, eliminate? Wouldn't that eliminate the variable y? Yes, right? So you should notice here that if we decided to actually add these two equations up, and we literally join these two by joining together the like terms that are in these two equations, right? That again, the variable y in this particular case, the variable y would be canceled out. Right? So we should notice that. All right, and guys, the way that you notice, the way that you know that one of the variables is going to be canceled out when you add them is if the coefficient of one of the variables, if the coefficients of so for example, with the variable y, if the coefficients of like that variable are opposites. Guys, and what we mean by opposites, we mean the additive inverses. In other words, when you add those two coefficients together, they're going to cancel each other out. Like for instance, guys, the two coefficients for y, the coefficient for the top one is -1, and the coefficient for the bottom one is +1. Those are opposites, -1 and +1. They're opposites, or in other words, they are additive inverses. And so when we add together -1 and +1, they cancel each other out. Okay? And since this equation was already written in that particular way, guys, we don't have to, like I said before, we will only multiply those equations if it's absolutely necessary. And guys, in this particular case, it's not necessary. Alright, so again, guys, because the coefficients of y are the same number but different or opposite signs, then guys, we can go ahead here and we can add these two equations together. So again, we're gonna go ahead on and add these two equations together because again, when we do that, it should cancel out or eliminate this variable, the y, and you'll see that. All right, so guys, let's go ahead on and add these two equations together. Again, guys, we're gonna add them together by combining the like terms on the same side of the equation. So again, let's go ahead on and do that. Let's add, boom, boom, boom. Wait, yeah. Try that again. Okay, a little bit better. And I don't know how straight that line's going to be. You guys get to see my ruler again. If it'll pop up, there we go. Yeah, I hate non-straight lines. Ooh-wee. We're going to try to get that there. Let's add these two together. Bye, ruler. Alright, so 4x minus 2x, or 4x plus negative 2x. Alright, we should know what that is, shouldn't we? Shouldn't we? I know it. You need to know what that is. Alright, 2x, right? When we combine those two like terms there, because they're on the same side of the equation, they're both on the left side of the equation. Even if they're in two different equations, they're both on the left side of the equation. Alright, so 4x plus negative 2x gives us 2x. Negative y plus y. Again, guys, that cancels out. That's what we want it to happen. We want it to be able to add these two equations together so that one of the variables would cancel. And that's what's going to happen. I'm going to do it one more time. Negative y plus y. That's negative 1y plus 1y. It cancels. Look at that. All right. It cancels out. That's exactly what we wanted to happen, guys. All right. And so now we've combined those like terms on the left side of the equation. Now let's combine them on the right side of the equation. 29 plus negative 15. 29 plus negative 15 gives us positive 14. All right. So guys, after we have successfully added the two equations together, and again, guys, we only want to add those two equations together if when we add the two equations together, it's going to cancel out or eliminate one of the variables. So guys, if we have successfully and if we've added these two equations together successfully, that means that now one of those variables has been eliminated, and now you should only see one variable in this new equation that we have created here. All right. Okay, so let's go ahead on and solve this equation. Let's solve it for that variable. So let's divide by 2 on both sides, and we get that x equals 7, right? Are we done? No, folks. Why are we not done? Because remember that when we're finding solutions for a system of equations, the solution is not just an x value. The solution is an ordered pair in the form of x, y, right? So what do we need to do? Now that we have found the value of one of our variables, we need to plug in that value into one of our original equations, and we need to use that to solve for the other variable. All right, so let's go ahead on and do that. And it doesn't matter which of those two equations, which of the two original equations you choose to plug in that x value into. I'm just going to choose the first one because it's the first one I see. So 4x minus y equals 29. And again, folks, we're going to substitute that value of 7 into this equation, and we're going to use that to find. Okay, that's not really the way I wanted that to look, however, yeah, and it doesn't look like it's going to do it the right way, so it's all's right. It's okay. Now that looks better. Alright, so again, we're going to substitute that value 7. Yeah, except for I drew that completely to the wrong variable. Why y'all let me do that? Alright, so again, guys, make sure that you substitute that value that you have, x equals 7. Make sure you substitute it into the right variable, because you saw what I just now did, right? And again, I saw my mistake because I'm a math teacher. But again, just because I'm a math teacher and you're a student doesn't mean that you can't also find your mistake if you make one too. Anyway, so again, make sure you plug that into the right variable. We're plugging in 7 for x. And so when we do that, we're going to have here 4 times, yeah, I didn't want that to be written in black. Give me just a sec here, guys. That's going to be 4 times 7 minus y equals 29. And we use that to solve for y. That gives us 28 minus y equals 29. We subtract 28 on both sides. We end up having negative y equals 1. Guys, we're not done yet because this is still negative y. In order to finish solving, we've got to divide by negative 1. Sorry, I ran out of space. Oh well, my bad. I wish I would show the dividing by negative 1, but if you don't know by now what that looks like, I'm so sorry, folks. You should know what it looks like when we're dividing both sides of the equation by negative 1. Anyway, y winds up being -1 here, okay, and the solution here, because we need to write it out as an ordered pair, the solution for this particular system of equations is the ordered pair of 7, -1. We're going to look at a few more examples. Wow, yeah, that's not -1. There we go. We're going to look at a few more examples of where we're solving systems of equations, linear systems of equations, using the elimination method. And then, guys, we're going to look at non-linear systems after that. Okay, so let's look at this second example here where we are solving this system of equations using the elimination method. So guys, again, with this one is slightly different from that first example where we were solving using the elimination method. How is this one different? Well, in the first example that we looked at with solving using the elimination method, we had one of the coefficients of one of the variables were opposites or additive inverses. So in that first example, the coefficient of one of the variables were technically the same number, but it had different signs. We don't have that. We don't have that with this example. So guys, in this example, what we've got is we've got where one of the coefficients. So if you look at just one of these variables here has coefficients such that one of them is a multiple of the other one. You guys remember what multiples are? You remember multiples? So if you look at these two numbers, 3 and 6, remember multiples of 3, and I'm going to erase this real quick. Multiples of 3 are numbers like 3, 6, 9, 12, right? Multiples of 3, 15, 18, right? If you keep on going, it's like counting by threes, right? So the coefficients of that variable x are numbers such that one of them is a multiple of the other one. All right, and let me erase that. Big eraser. All right, so since we've got one of these numbers here, the coefficients for x, 3 and 6, right? One of them is a multiple of the other one. What we're going to do is we're going to need to multiply just one of the equations here. And we want to multiply one of those equations so that these two numbers, the 3 and the 6, so that they'll wind up being technically the same number, but with different or opposite signs. In other words, we want to multiply one of these equations so that those two numbers are now going to be the additive inverses or opposites of each other. Alright, so folks, that was the first example. Again, we're going to look at a few more examples. Alright, coming right up. Alright, so here we go, example 2. You can see what this says, 3x. Oh, I'm sorry guys, my bad. I had a brain fart for just a moment. I forgot that I had already shown you this, and I had already really talked about the fact that that when you look at the coefficients for these variables, that one of these, and specifically when you look at the variable x, one of these has a coefficient that is a multiple of the other one. Yeah, I forgot about that. My bad, y'all. Alright, so again guys, here you can see that again those coefficients for x are in such a way that one of them is a multiple of the other one, right? So you can clearly see here that 6 is a multiple of 3. And so again guys, since 6 is a multiple of 3, we're going to And again, I've shown you, or I've explained to you what multiples are already. But again, since 6 is a multiple of 3, think about what number do we have to multiply 3 by in order to get 6, all right? And that's going to help you. That's going to help you determine which equation you're going to be multiplying by a constant factor, all right? So clearly, guys, we're going to multiply the first equation times some number, right? So we're going to multiply the first equation times some number, that first equation, which is 3x plus 4y equals 14. And we need to multiply that times some number, times some type of constant factor, so that, and we multiply that times a constant factor so that those coefficients will be opposites of each other. So again, guys, in order for that first coefficient to be an opposite or additive inverse for 6, that means that it would have to be the same number and it would have to have the opposite sign, right? So what would we multiply 3 by in order to make that become -6? All right, so again, guys, really quick, I'm going to write that, but I'm going to erase it. We want the two numbers to be 6 and -6, so that when we add them together, they will cancel out. Okay? And again, that's the whole purpose behind using the elimination method. So that when we add these two equations together, one of the variables will cancel out. And they'll only cancel out if those coefficients for that variable are opposites or additive inverses, like 6 and -6. So again, I'm going to erase that real quick. And again, guys, you should know what number we have to multiply that first equation by in order to make that coefficient so that it is the opposite of +6. Oh, I'm so glad that you said the right thing, y'all. Yes, we're going to multiply that times -2. We have to multiply the first equation times -2. Okay, yeah, give me 1 second now. We got to multiply that first equation times -2. Yeah. Alright, and again, guys, the second equation is still 6x minus 3y equals -27. Alright, so guys, I'm just going to rewrite this whole thing over again. And so I'm showing you what we're doing, exactly what we're doing. We're multiplying this first equation times -2, and as of right now, we're going to see exactly what this looks like after we multiply this. So if we multiply the entire first equation times -2, you need to, in other words, distribute this -2 to every term. Distribute that -2 to every term on both sides of the equations. All right, so we need to multiply the -2 times 3x. All right, when we do that, that winds up being -6x. We need to multiply the -2 times the 4y. That winds up being -8y. And we need to multiply the -2 times 14. That winds up being -28. All right, so we've multiplied that first equation times a constant factor. All right, and I'm just going to rewrite the second equation here. What was that? Minus 3y equals -27. Yeah. Alright. Okay, so again, guys, at this point, we are ready to go ahead and add those two equations together by combining the like terms on the same side of the equation. Folks, remember that again, after you add these two equations together, you should have eliminated one of the variables. And there should only be one variable remaining in this new equation. Guys, if you get ready to add these two equations together and you realize that okay, if I add these two together, if you realize all of a sudden that you're not going to eliminate or cancel out one of the variables, what that means, guys, is that you've technically multiplied times the wrong number. You did something wrong. Okay, if you've multiplied one of the equations by a number and after doing that you realize that adding the two equations together is not going to cancel out one of your variables, yeah, that means you've done something wrong. But anyway, guys, we've done something right here, okay, on this video. So we're going to add these together, and when we do, we'll see that one of our variables will be canceled out and we'll only have one variable left, one variable remaining in this new equation. Guys, we will solve for that variable. Let's go ahead on and work that out. So let's add these two equations together. Okay, so again, guys, we're adding these together. Yeah, you know what I thought that was going to do, like this right here. It ain't doing it though. It's okay. It's all right, y'all. All right, so we add that together, and we combine those like terms that are on the same side of the equation. When we add together the negative 6x and 6x, again, folks, that is going to cancel out. That's exactly what we want it to do. Exactly what we want it to do. So it cancels out here. Alright, and then, guys, when we add together the negative 8y plus negative 3y, we get negative 11y. Oops, give me a sec. There we go. I'm going to change that right there. Negative 11y. Yep. Alright, and when we add together the like terms here on the right side of the equation, negative 28 plus negative 27, that gives us negative 55. And again, guys, we see here with this new equation that we've created, there's only one variable left. We're going to solve for that. And right now, there's only one thing left to do to solve. We're going to divide by negative 11 on both sides of the equation. Divide by negative 11, divide by negative 11. And we get here that y equals positive 5. If we do negative 55 divided by negative 11, we get that y equals positive 5. Guess what, guys? Are we done? Absolutely not, right? Because I've repeated several times that again, our solution for a system is not just an x value and a y value. And by the way, we haven't even found an x value yet. But guys, our solution is an ordered pair, where you have to write it as an ordered pair in the form of x, y. So again, now that we have found one of those variables, we need to go ahead on and substitute that in to one of our original equations, and we need to solve for the other variable. Alright, so again, folks, we're going to go ahead on and we're going to substitute that value for y. And guys, again, folks, it doesn't really matter which of those two equations you choose to use. I'm just going to choose the first one because it's the first one that my eyes behold. So let's see here. 3x plus 4y equals 14. Alright, so again, we're going to substitute that value of 5. And we're going to plug it in for the y value here. Alright, so let's plug that in right there. Yep. Alright, and so let's plug that in. Excuse me. Alright, and so let's do that there. That's 4y. Alright, so guys, for this we've got 3x. We still have the plus 4. And again, instead of us writing y, we're replacing that with the value there, 5. and the rest of this equation still says equals 14. Alright, so let's simplify and solve for this variable x, right? So that's going to be 3x plus 20 equals 14. We're going to subtract 20 on both sides. That's going to wind up being 3x equals negative 6. And then the last thing for us to do here is divide by 3 on both sides. So when we divide by 3, we end up getting that x equals negative 2. Alright, so here we've got that y equals 5, x equals negative 2. Are we done, folks? Is that our solution? No! Right? We need to make sure we write our solution as an ordered pair. Our solution here is the ordered pair in that xy form, right? That ordered pair of negative 2, 5. Alright, and that's the way the cookie crumbles, folks. Right there. Next example coming up.